You know, when I think about OWL, Sparkle, RDF, but we need to think about it in business. I'm here to tell you from the acquisition visibility perspective, we work with the services and cooperatively set what data that is and what context it's in. We work with them to set what is the authoritative source, where is that authoritative source in our use construct, and how they're going to get it to us. We are setting the next breed of analysis that are data-driven. We want seamless and transparent, and we want to empower leadership. Semantics ontologies are critically important for us to set that stage for that transformation to occur.
Hello, my name is David. I'm here to explain the DoD plan to meet the growing information needs of our services and also to show you what we're doing to make business operations within DoD less expensive, more efficient, and more flexible. Today, DoD services, agencies, and components increasingly find themselves in a joint environment and require access to data across services and components to provide support and make informed decisions. Traditionally, we've relied on raw human effort, custom software, and a lot of public dollars to meet those needs. But we don't have the manpower or the money to continue to operate this way. Semantic technology helps us solve this problem. Let's listen to a few stakeholders who can tell us of their experiences with semantic technology.
I'm Mike Renner from the United States Military Entrance Processing Command. Here at MEPCOM, we are building our executable architectures based on BPMN 2.0 primitives compliant business process models, constrained by LRPs and requirements for each business process area. We seek an end-to-end development framework from BPMN to RDF and OWL and back. This allows an ontology-based transparency to communicate bidirectionally with the DoD business enterprise architecture. This results in a standardized development process to develop, test, and check business process models, execute those models, and merge them as OWL into the BEA. This semantic integration supports new initiatives here, like electronic health record access. To remain objective and competitive, regardless of which tools we use, we strongly support a government-driven, standards-based approach that spurs innovation from tool vendors and provides the DoD an assurance of business solution success.
Hello, I'm Jonathan Underley of the Business Mission Area's Enterprise Information Web. The mission of EIW is to provide information visibility at the Department of Defense enterprise level. The EIW solution is applying a set of industry standards, including Resource Description Framework and Web Ontology language, commonly referred to as Semantic Web. The EIW approach is to model and align disparate information resources using these web standards, which together allow the military services to maintain the information systems required to complete their missions while maintaining alignment to a common vocabulary at the enterprise level that supports analysis and policymaking. The proof of delivery, or POD concept, is the method EIW has employed to package functional and technical proofs in 90-day increments. We have completed 9 pods since October 2009, proving that semantic technology works and can provide a cost-effective solution to the DoD enterprise information and analytic needs. EIW, using semantic web technology, should allow the department to have visibility of personnel, pay, logistics, and other information at the enterprise level using authoritative data.
You just heard from a couple of stakeholders who have experience with semantic technology, but no technology stands alone. Imagine the government stakeholder as a pilot. To stay in the air, a pilot has to manage heading, altitude, and airspeed. These 3 things form the flight plan. Our plan for the DoD relies on business processes, the cloud to deliver processes and data, and the semantically understood data itself. Business process models provide a heading by pointing to the authoritative data source. Business process models are part of a neatly wrapped package called service-oriented architecture. SOA executes the business process model for business applications. Business models must be recognizable and understandable by others in the services and in government. It isn't just the pilot or stakeholder who must know where he is going, but flight controllers and those that serve on the ground. This means that all business processes must be modeled with the standard notation that everyone can read, just as flight charts can be read by anyone. The standard notation is the Object Management Group Standard BPMN 2.0 Conformance Class. BPMN describes a workflow map, and it can also be the executable representation of an automated process. Now, to create an accurate and executable business process model, we need a ground crew with some new specialties. There is a sponsor or process owner who defines the problem statement and sets the goals and objectives of the project. A project manager who manages the scope of the effort to ensure a successful solution. A systems developer who has the programming language expertise. He or she participates in the design, development, testing, and implementation of the process model. A solutions architect who can create a solution that fits the overall architecture of the business. A business analyst who understands the mechanics of semantic technology and the business of DoD. And an ontologist who creates a language to describe the data and the business processes that touch it. In addition to the heading, a pilot has to consider his altitude. Altitude is the evolution to a cloud that contains our automation environment. It is the hardware, software, and networks that house and provide data. Business process models enable us to navigate this cloud by defining the orchestration of SOA business processes and by making data remotely accessible in the cloud. The cloud also provides infrastructure, platform, and core application services. The National Defense Authorization Act of 2012 strongly encourages DoD services and agencies to use commercial cloud providers before considering a government provider. The federal CIO calls it Cloud First. The Defense Information Systems Agency offers enterprise IT shared services that can be mixed with commercial and private vendors, making it possible to choose the most effective and efficient composite solution. The third element a pilot must consider is airspeed. We will liken a pilot's airspeed to the velocity with which we can use and consume data in the cloud. Speed is needed to stay in the air. Speed is also needed to get into the air. As the amount of data increases, getting into the air and staying there become increasingly difficult. If our ability to consume data slows, our airspeed drops and we stall. The real problem with data is that we have as many queries for a given question as we have systems we query. We tend to build custom systems to ask specific questions of different authoritative data sources. These custom systems are very expensive to build and maintain and take a lot of runway to get into the air, more runway than we have. What we must have is a single way to ask the same question of every system. For this, we need semantics. We need the data in our cloud to be understandable by all systems in a cloud of semantic data, a semantic web. Semantics enables us to represent data in a way that is both machine-readable and human-readable. When we standardize the semantics of our data, we can query and consume data from a system without a custom query. Queries become portable between systems. Semantic data models are used to represent concepts, entity types, properties, relationships, and operations to specify data semantics for the domain constrained by the business process model. As a result, the speed with which we can consume data improves and the cost of information drops. Semantic technology eliminates the need for multiple customized systems and provides meaningful data and information. It enables us to get into the air with a shorter runway and stay in the air at a much lower cost. For our conclusion, let's hear from a real airplane pilot who is sponsoring our efforts in mapping out the right course in fulfilling the DoD semantic vision. Dennis Wisnowski.
Thank you, David. A successful pilot considers the resources that maintain a direct course to his or her destination. The pilot must consider those resources that he or she knows, understands, and trusts. Heading, altitude, and airspeed are those flight resources that affect each other. Similarly, the DoD understands that its business operations and its information can never be improved in a lasting way without re-engineering supporting business processes. That's our heading, and that those business processes will be orchestrated worldwide in our cloud. And most importantly, these business processes must consume semantically understood data, our airspeed. It takes all three together to meet our responsibilities to the taxpayer and, most importantly, to the warfighter. Thank you for listening, and we see each other in the cloud.